Okay, I'm doing some more testing. I'll show the advantage of the second switch that connects the flyback to the caps rather than sending it directly there from the steering diode. So again, with nothing happening, just the motor going, it's 10 milliamps. And here's the amperage going into the load of the 17.5 ohms coil. And here's the voltage in the cap bank. So I have 4 volts in the cap. I only have a single cap being filled at 220 UF right now. So I thought I'd try a much smaller cap, see what happens. So over here, this red wire with the red tape on it, this is the hot wire coming off of the steering diode. This will what give you a big shock right here if you touch ground. And right now I don't have that hooked up. Here's the other end of it. So if I put it over here, I'll bypass this switch, and this will take it directly into the cap bank. Okay, so I'm going to do that right now. So when I connect this, the cap should fill up pretty fast. 1, 2, 3. Here we go. It's filling up. 23 at 30 volts. I'm gonna. There. Now I'm pulsing into the load of this here, and you can see the amps. Here's the amps, and I only have 5 volts in it. But listen to this. The rotor was at 500 RPM before, without filling the cap. Now listen to the rotor going down, and the draw is flashing up pretty high to 40 milliamps. So this is without the second switch, the 5 degrees retarded switch that connects the flyback to the caps. Okay, so now I'm going to not have it bypassed. Okay, put that down there. Now it's still pulsing into the load, so it brought the volts down to nothing, and it's not being pulsed to the load now because I disconnected this battery, so the switcher is not pulsing the cap into the load now. Also, this is between the load and the switching. That gives the highest reading for amperage. Okay, now watch this. When I connect this other lead right here, this will fill the cap with the switcher at 5 degrees retarded. The second switch will be connected to fill the caps in that method, not straight into the caps from the steering diode. Here's that steering diode. It's on the drain of the MOSFETs. Okay, ready? There we go. Now, volts goes up pretty fast, just about same speed the volts go up in the cap. Now at 30 volts, I'm going to connect the battery. Okay, so there's the amperage going in right here. And here's the volts in the cap bank, only about 3 volts, 2.9. But look at this. The rotor's going much faster, and the draw is pretty much steady at 20. So there's the advantage if you have a motor. It doesn't kill the rotation so bad. It doesn't cause excessive draw. And you get about the same output into the load. So there's this test here. Okay, thanks for watching. Okay, bye.